Imagine stepping outside on a normal night, but something feels wrong. The moon is not there, not fading, not eclipsed, simply erased from the sky. In the first few seconds, most people wouldn't even understand what they're seeing. Across the world, astronomers are the first to react. Observatories light up with alarms as tracking systems suddenly lose the largest natural object in Earth's orbit. Telescopes point to empty space. Social media explodes with the same question from millions of people at once. Where did the moon go? In coastal regions, nothing dramatic happens immediately, but scientists notice instruments behaving strangely. Tiny changes in gravitational measurements appear within minutes. The oceans don't surge yet, but the invisible balance holding Earth and the moon together has already snapped. Psychologically, the impact is instant. The night sky feels deeper, darker, and unsettling. The moon has always been a constant, watching over ancient civilizations, guiding travelers, shaping myths. Its sudden disappearance triggers fear, disbelief, and a profound sense of loss. Religious leaders, scientists, and governments rush to speak, but no one has answers. In that very first hour, before any real destruction begins, humanity realizes something terrifying. We've lost more than a glowing object in the sky. We've lost a silent partner that has been with Earth for billions of years. The most dangerous changes after the moon disappears don't arrive with explosions or visible chaos. They begin silently, through gravity, an invisible force most people never think about. The moon isn't just hanging in the sky, it is constantly pulling on Earth. That pull shapes our oceans, subtly stretches our planet, and keeps long-term balance in motion. The moment the moon vanishes, that gravitational relationship is severed. Within minutes, sensitive instruments detect the change. Earth is no longer being tugged sideways by its closest companion. The planet relaxes slightly, like a stretched rubber band suddenly released. This shift is small, but on a planetary scale, even tiny changes matter. The most immediate effect is on the oceans. Normally, the moon's gravity pulls ocean water toward it, creating tidal bulges on opposite sides of the planet. Without the moon, those bulges weaken drastically. The sun still causes tides, but they are far weaker. On land, nothing appears broken, but Earth's internal systems feel the loss. The moon also helps regulate stress in Earth's crust. Without its pull, subtle changes occur in how tectonic forces distribute pressure. Scientists wouldn't feel earthquakes immediately, but models begin to predict long-term instability. For thousands of years, Earth's oceans have followed a reliable rhythm, rising and falling like a planetary heartbeat. That rhythm is controlled mainly by the moon. When the moon disappears, the oceans don't explode into chaos immediately. Instead, something more unsettling happens. The tides begin to fade. Within days, scientists confirm the change. The powerful lunar tides that once pulled trillions of tons of water across the planet are gone. Only the sun's gravity remains, creating much weaker tides, about 30% of their former strength. Coastlines that once experienced dramatic high and low tides now barely change at all. Water stops flushing in and out of bays, estuaries, and wetlands. This is where real damage begins. Many marine ecosystems depend on tides to survive. Nutrients stop circulating. Oxygen levels drop. Coastal plants rot in stagnant water. Fish nurseries collapse, followed by shellfish, coral reefs, and entire food chains. One of the most productive ecosystems on Earth begins to suffocate. The moon does more than pull on Earth's oceans. It acts like a stabilizing weight on a spinning top. Earth rotates at a tilt of about 23.5 degrees, and that tilt is the reason we have predictable seasons. The moon's gravity helps lock that tilt in place. When the moon disappears, Earth loses its stabilizer. At first, nothing seems different. The axis doesn't suddenly flip. But over years and centuries, Earth begins to wobble. Without the moon's steady gravitational grip, the planet's tilt starts drifting unpredictably. As the tilt changes, seasons become unstable. Summers grow brutally hot in some regions, while winters turn catastrophic in others. Areas near the equator could freeze, while polar regions might experience scorching heat. Ice caps melt in irregular patterns, then reform elsewhere, accelerating sea level chaos. This instability puts enormous stress on ecosystems. Plants and animals evolved around stable seasonal cycles. Migration, breeding, and agriculture depend on them. When seasons stop behaving, crops fail, food chains collapse, and mass extinctions become likely. The moon doesn't just affect oceans and weather, it controls time itself, at least the way we experience it on Earth. For billions of years, the moon's gravity has acted like a brake on our planet's rotation. Tidal friction between Earth and the moon slowly steals Earth's rotational energy, making our days longer over time. When the moon disappears, that brake is suddenly released. Earth begins to spin slightly faster. The change isn't dramatic overnight, but it's measurable. Over centuries, days slowly shorten. A 24-hour day becomes 23 hours, then 22. Eventually, the rhythm that life evolved around begins to drift. Clocks still tick the same, but the natural cycle of light and darkness no longer matches biology. This creates deep problems for living organisms. Human circadian rhythms, our sleep, hormones, focus, and mental health are tuned to a stable day-night cycle. Even small shifts cause insomnia, anxiety, and long-term health issues. Animals suffer even more. Migration patterns break. Hunting and feeding schedules fall apart. Plants struggle too. Photosynthesis depends on predictable light exposure. Faster day-night cycles stress crops and forests, reducing growth and yields. Entire ecosystems lose synchronization. The moon's disappearance doesn't just affect Earth. It sends shockwaves through human technology and our future in space. The moon has always been our closest testing ground, a stepping stone between Earth and the rest of the universe. When it vanishes, that bridge is gone. Satellites in Earth orbit don't immediately fall from the sky, but their long-term stability is affected. The moon's gravity subtly influences satellite orbits, helping keep some trajectories predictable. Without it, engineers must constantly correct paths, increasing costs and failure risks. Space exploration takes a massive hit. Decades of planning for lunar bases, mining, and deep space launch platforms instantly become obsolete. The moon was meant to be humanity's training ground, low gravity, nearby, and perfect for testing life support systems. That opportunity disappears overnight. The moon's disappearance reveals one of its most vital roles. It has been Earth's silent guardian. Beyond tides, nights, and seasons, the moon has acted as a cosmic shield, intercepting countless asteroids and comets that would otherwise have slammed into Earth. For billions of years, it absorbed impacts that could have triggered mass extinctions. Its cratered surface a record of what could have hit us. Without the moon, Earth is left exposed. Even small asteroids that would have previously struck the moon, over centuries, the probability of collisions with catastrophic consequences rises sharply. Imagine a planet where extinction-level events become more frequent, simply because the object that once took the hits is gone. After exploring the chain reaction of disasters triggered by the moon's sudden disappearance, one thought lingers. Could Earth have ever existed without it? Every aspect of life, the tides, the seasons, the stability of day and night, even the survival of species, has been quietly guided by this silent companion. Without it, the planet becomes unpredictable, hostile, and vulnerable. Humanity would face a world of shorter days, collapsing ecosystems, chaotic weather, failing crops, and darkness unbroken by moonlight, and centuries of cultural and emotional connection to the moon would vanish overnight. Beyond the immediate consequences, Earth's long-term habitability would be threatened by erratic axial tilt, extreme climates, and increased asteroid impacts. This isn't just science fiction, it's a thought experiment about how much we take for granted. The moon isn't just decoration in the night sky, it has been a guardian, a stabilizer, a cosmic partner that made life on Earth possible. Its absence shows how delicate the balance of our world truly is, and how much of what we call normal is the result of billions of years of silent cosmic collaboration. So we are left with a haunting question for the mind to wander. Was Earth ever truly meant to survive without the moon? And if the moon can disappear in imagination, how fragile is the world we rely on so heavily, both physically and emotionally? The answer is uncertain, but the thought alone reshapes the way we see our place in the universe.